So we're going to continue talking about things that violate the octet rule. Um, and we're going to be going through the fives, and then we'll go through the sixes. These aren't like super common, but they're fun, and so I kind of wanted to show you. Just so you recognize when you're given something that violates the octet rule, how it works out. And plus, it's a nice way to look at naming. And I don't think I named that last one. I believe that was phosphorus pentachloride, but so anyway, I'll make sure to do this one. So this is the formula we have now. This is SF4, so you got 1 sulfur and 4 fluorine. So the first thing to do is let's figure out and make sure this is a covalent compound. So the fluorine has an electronegativity of 3.98. The sulfur has a 2.58. So 0, 4, 1.4. Again, pretty polar. You're going to notice that when these things are violating the octet rule, because the only elements that can force another element to violate the octet rule, they have to be very, very electronegative. So you're going to get a big difference there. But it's not the 2 that we need in order for this to be an ionic compound. And again, we wouldn't expect it to be an ionic compound because sulfur has 6 valence. That means that it wants to gain 2 or make 2 bonds usually, except in this case. And then fluorine has 7 valence electrons, which means it only needs to gain 1 electron or make 1 bond. Okay? So remember, these are both nonmetals, and when they get together, they're not going to make an ionic compound, they're going to make a covalent compound. Now, what kind of messed up covalent compound are they going to make, though? Let's see. So sulfur, you got 1 times 6 is 6. Fluorine, you've got 4 times 7 is 28. So 6 and 8 is 14. Oh my gosh, it's 34 valence electrons. So we've got 34 electrons to put out here. Okay, so I know that sulfur has to be my central. And then what that is going to be is, let's attach all the fluorines. Good. Okay, so 2, 4, 6, 8. -14 8 is 6. So I've got 26 left. All right. Now, 6 times 4 is, so I've got 26 left. So if I give each fluorine what they need, that's going to be 6 times 4 is 24. So let's do that. 1, 2, 3, 4, 5, 6. And that leaves me 2 electrons. Now, a lesser chemist will say, well, sulfur's got 2, 4, 6, 8. Each fluorine's got 8. Let's just leave them 2 off. No. We can't do that because we can't just remove valence electrons just because it's convenient. And so, since fluorine isn't going to violate the octet rule because it really only wants to make 1 bond, and it's too small to violate the octet rule. That's really the more important thing. Because you'll notice the bigger halogens like chlorine and iodine will violate the octet rule, but fluorine, again, it's filling in that 2p, and so it can't violate the octet rule. Other than the fact that, if something's going to violate between sulfur and fluorine, it's going to be sulfur because sulfur's bigger and it wants to make more bonds. But we need to put those 2 electrons on the sulfur, and that's what makes it a violator. Boom. So we could do formal charges and talk about that. So sulfur has 6 valence, and it has 2 unshared plus 2, 4, 6, 8. 1/2 of 8 in bonds is 4. 2 and 4, 6. So sulfur has a 0 formal charge. And then the fluorine, it has 7 minus 6 plus 1/2 of 2 is 1, and so it's 0. So the formal charges, they work out, okay? Now, this is one of my absolute favorite structures to draw. Just go to the chart at this point until you kind of learn it. And, you know, when you're getting to the violating ones, they are always going to be a little esoteric, and that's okay. Make sure you got your tetrahedral down and those, you know, anything based off tetrahedral. But, you know, your violators are your fun ones. And so that's why I like this guy, because, oh my gosh, I used to make so many mistakes doing this one. Okay. I was worried when I started this I might make a mistake on this video, but it's going great so far. And so that's my 3D drawing, okay? And that unshared pair pushes everything down like that, okay? And so these are in the plane here, and so that is like that. And then you got 2 more that are like that kind of. And then you've got your unshared pair right there, okay? And so this is as far away as everything can be, okay? And so when we look at that structure, it is, everything is 90 apart, and I'm going to try to show you that. So like here, and then there's one down here, and then the unshared pair is kind of right on top of where all the pins are meeting. But when you make that structure, it reminds people of a seesaw. So it's 90 degrees, and we'll call it a seesaw structure. We won't call it that. We'll call it that because that's what it is. But I've also heard that one called hobby horse. And then I think one time in class I made the great error of calling it seahorse, and people thought that was really funny. So just remember, you don't have to be perfect, just so long as you eventually get it.